Imagine the following use case. I am a researcher interested in the environmental influence of seismological events in the center of Italy. To solve this issue, I have to look for some datasets. These datasets will concern many scientific domains like atmosphere, aquatic, or solid ground. So I will have to use a VRE, or virtual research environment, that allows to search across resources coming from various communities. In order for resources to be searchable, datasets in our example, resource providers need to describe them using metadata. And these metadata need to be managed in the catalog of the search engine of the VRE. So the question is, how to best design this catalog and integrate metadata within it? Hello, I am Laurent Remy. I'm currently Deputy Leader for the Serif Task Group at Eurocris, a not-for-profit association bringing together experts on research information systems. Eurocris also curates Serif, the Common European Research Information Format, a data model representing metadata about research entities and the relations between them. I'm also an IT consultant for IS4RI, a small company that goal is to help implementing information system for research and innovation. Let's go back to my use case. As a researcher, what I want to do is to query and browse the resources of a catalog. Several steps are needed to feed this catalog. The first step is to identify the data providers and the metadata format they use. These providers can be any endpoint that offers research metadata, data portals, ERIs, etc. To describe metadata, providers may use existing standards or their own specific metadata formats. These various formats must be translated to the format of the catalog. This operation is called schema matching. The objective of this step is to make some connection from the entities and properties of the source format to entities and properties of the catalog format. Once the schema is matched, metadata is harvested from the providers and transformed to the target format using the corresponding matching. This step is called mapping. The mapped data are then imported within the catalog to be available for browsing and querying. In this lecture, we will study the metadata service, which is part of a VRE architecture. This service is responsible for importing and querying the metadata. During this video, we will see how this metadata service has been designed and implemented in the context of the VRE for EIC project. VRE for EIC defines a reference architecture for an eVRE, or enhanced VRE. This architecture defines 6 conceptual components to support the research process within the eVRE. The component that interests us in this video is the metadata manager, which is responsible for storing, manipulating, and exposing metadata about resources, user profiles, provenance, etc. All data used by the other components. VRE for EIC also provides a technical architecture using microservices, which have been derived from the 6 components of the reference architecture. The metadata manager component has been implemented in the metadata service. This implementation contains all the methods that can be used for metadata management, namely import, export, query, and update. It also contains the required methods for the mapping and transformation of metadata coming from providers into the catalog. 4 subcomponents are implemented in all the services of the architecture. 3 subcomponents are specific to the metadata service. The resource manager provides the ability to retrieve, update, and remove resources. It relies on other components, for example, the metadata manager for storing the metadata, or the AAAI service to check permissions. AAAI is authorization, authentication, and accounting infrastructure. The data model mapper is responsible for the transformation of data between different formats. It implements the mapping operation that we talked about in the presentation of this video. Finally, the metadata manager is implementing using a triple store for the eVRE, as metadata is stored using the RDF expression of the Serif metadata model. Different existing technologies have been used for the current metadata service implementation. Subcomponents also have been developed within the VRE for EIC project. One specific tool is used as data model mapper. This is the X3ML toolkit. This toolkit includes several tools. The first one is X3ML, an XML-based language which describes schema matchings. This language homogenizes the way a matching is described. The second one is the X3ML engine that realizes the transformation from the source records to the target formats by applying a predefined schema matching expressed in X3ML. Finally, 3M, or Mapping Memory Manager, a tool for managing matching definition files. This tool comes with an online editor and helps experts during the definition of the matching. Let's have a quick look at this tool. When describing a matching using 3M, the first step is to define the context. What are the sources and target schema, and the various namespaces that will be used. 3M will automatically parse the two schema to help us during the definition of the matching. The second step is to define the matching from source entities to target entities. Entities are matched using the D element of 3M, D for domain. In this example, we match a DCAT dataset to a serif product. For each domain, we can then specify multiple properties and ranges to match the attributes of the entity. The property element refers to the attribute, and the range element defines the type of the value. At each step, 3M helps us by proposing the available properties and ranges for the current entity, depending on the schema. Once the matching has been described, the generators must be set. Generators allow 3M to know how to build the values, like URIs for example, or get them from the source using XPath. Various generators are built in to solve most of the cases. These three steps are the basic ones to describe a matching using 3M. This description is stored using X3ML, the specific language of the toolkit, and is obliged by the X3ML engine to automatically map source records to the target formats. So, the metadata service is a service defined by the VRE architecture that is responsible for managing metadata. Managing metadata includes homogenizing the formats of various sources to the target catalog, using two operations, matching and mapping. VRE for EIC defines an implementation of this service that uses the X3ML toolkit to manage these two operations. Some metadata formats have already been mapped to serif using 3M, including DCAT AP, CCAN, or ISO 19139, for example. Apart from the matching of metadata formats, some work also needs to be done regarding semantic homogenization. The quality and effectiveness of the matchings also need to be documented. Here are a few resources if you want to know more about the eVRE architecture and the metadata service or the X3ML toolkits.